Alrighty, for the first warm-up, we have r equals 5 cosine theta. So we recognize this one as the circle has a diameter of 5 and it wraps itself around the x-axis. So 1, 2, 3, 4, 5. And then we just attempt to draw a circle. Oh my goodness. If it does not look like a circle, you should probably label it as a circle. Now, one thing that we can actually do when we're thinking about this is connect this to rose curves. This is actually a one-petal rose curve. It follows the same pattern. The k value is 1. That means that we can find the max r, which is going to be 5. It starts, because it's cosine, at 0. So here we go, 0, and we have a single petal. Done. Next one, we got r equals 4 over sine theta. So we recognize this from the first half of the unit, where we're going to multiply this to the other side. R sine theta is really y, so this is really y equals 4. So that's a horizontal line, 1, 2, 3, 4, right there. Done. Okie dokie, next one, let's use our shortcut here. We know this is going to have 4 petals, twice the number on the inside, one's even. That means that each one of them is 90 degrees away from them. The max r is going to be 9, and I want to know where this thing starts. So it starts with cosine at 0. So I do 2 theta equals 0, so theta is going to equal 0. All right, so I'm going to pretend my scale is by 2, so max radius of 9 is going to be right there, and then I just go 90 apart. And then I draw. So here are my 4-leaf, 4-petal rose curve. Last of the warm-ups, we got r equals 9 sine 2 theta. So 2 theta has twice as many, so 4 petals, each one is going to be 90 degrees away from it. Its max r is going to be 9. Its starting point, because it's sine, we're going to set 2 theta equal to pi over 2. So theta is going to equal pi over 4 as our starting point. So I'm going to find pi over 4, which is right here, at 9, and then I'm going to just add 90 to each one of those. And here are the 4-petal rose curves. Now all of these petals are actually the same size, but I'm just not that great at graphing things nicely. My bad. Okie dokie, got a fancy new piece of paper going on here. Let's see, we got r equals 5 plus 5 cosine theta. So these guys are a special type of equations that are spelled like this, and there's like this weird French thingamabob on it. They're really Limassons, if we're being precise. I call them Lima Qs, because if you write that really fast, it looks like a Q, and it also annoys the BC Calc teachers that I call them Lima Qs. So I tend to just call them that, because I think it's funny. Shh, don't tell them. I'm going to try to graph this thing, so I just need to remember how to graph. This is going to raise me up to 5, so I'm going to have a midline right here at 5. And amplitude goes up and down 5, and it's cosine. So it starts up here, it's going to go down and back up. So here's 10 and here's 0. Okay, and I know that this is happening at pi. This is just a visualization. It's going to help us out a little bit later on. In particular, it's going to help us when we're doing the advanced polar graphs later on. So I'm going to fill in this table before I actually plot any points over here. But the thing is that this table is going to change depending on what I'm doing. So if I'm using cosine, I'm going to make sure that I always use the 60-degree angles, because that's always going to give me 1/2. If I used 30, cosine of 30 is going to be a square root of 3 over 2, and I have no idea what that is without a calculator. I mean, it's 0.866, but then multiply that by 5 plus 5, like, who knows? It's crazy. So I'm going to not do anything with the 30. So I'm actually just going to cross off everything that has a reference angle of 30 so that I don't get confused and want to use it. Now I'm just going to use this and also use the fact that the 60s are going to give me 1/2 to help me fill in the rest. So cosine is going to start at 10. Let's just actually do all the quadrantal ones. So right here is going to be 5 at pi. It's at 0. We're back at 5, and then we end at 10. Okay, so if I were to come over here and plot those, that's going to be here, 0, out 10. When I'm at 90, I'm going to be out 1, 2, 3, 4, 5. At 180, it's at 0. At 270, it's out 1, 2, 3, 4, 5. And then we're back at 10 when we're at 360. So I have no idea what this looks like yet. So that's where these are going to come in. So let's do this. I'm going to have 5 plus 5 times 1/2. Okay, so that's 5 plus 2.5. That's going to equal 7.5. And that's going to happen in 2 quadrants when cosine's positive. So in these 2 quadrants. So I can jump in and say that's going to be 7.5. and this one's going to be 7.5. And then if I want to, I can come over here and graph it. So I'm going to go 1, 2, 3, 4, 5, 6, 7.5. And then I like to just kind of trace all the way around until I find the next one so I don't have to recount. So now I'm getting a better idea of what this looks like. Let's do the negative one now. So now it will be 5 minus 5 times 1/2, because it really is negative 1/2. That's why this is negative. I can make that a plus and that a minus if that confuses you. But either way, I'm going to get positive 2.5 in the two quadrants that cosine is negative, so these two quadrants. So when I go to graph these at 120, I'm going to go 1, 2.5, and then I will keep my marker there as I trace around 2.5. And now I think we have enough that we can see what this looks like. So when we go to graph this, I always recommend that you start over here, because this does make a point and it's very round over here. And if we start over here, you're going to make this too pointy. So if I start here, I just kind of connect the dots and I make a big old circle-y shape on that side, and then it comes in. And if you're kind of squint at this, maybe it kind of looks like a heart. And its official name is actually a cardioid. Okay, cardio, like a heart doctor, cardiologist, or when you're running, cardio, heart, you get the name. No one's gonna ever ask you the name, so it doesn't matter. And we get this one when these guys right here are equal. So we call this A plus B. So when A equals B, we always get a heart, okay? I always like to say when you're equals with each other, you know, that's when you know that you're really in love. So you gotta treat each other as equals, something like that. I don't know, it's cheesy. I try to make you remember, who knows? Next, we got r equals 3 plus 6 cosine theta, okay? So I'm gonna jump over here. My midline is going to be at 3 this time. My amplitude is gonna bring me up to 9 and down to -3. And it's cosine, so I'm gonna start here and then I'm going to drop down and then back up. So I know right here, that's at pi over 2. Right here's at pi. Right there is 3 pi over 2. And right here is 2 pi. We're going to use our same little trick that we did earlier, but let's just start filling in as much as we can in the table here. So let's see, I still think that says 6, so make that 9. We're going to have 9, then 3, then -3. I forgot to cross off the ones we're supposed to not use, and I almost messed up. This one's going to be at 3, and this one will be at 9. So let me cross off all of those 30s so I don't mess up. All right, so now when I do the 60s, I'm going to have 3 plus 6 times 1/2, and I will also have 3 minus 6 times 1/2. So this will be in quadrants 1 and 4 when cosine's positive. This will be in 2 and 3 when cosine's negative. So let's see, math. That's going to be 3 plus 3, that's 6, so that's 6 and 6 for there, and here it will be 3 minus 3. Okay, so that's 0 and 0. Let's go ahead and try to graph this. So 0, 9 is going to be right there. 60 and 6, so 1, 2, 3, 4, 5, 6, and then I again like to travel around and hit its counterpart. 90 and 3, 1, 2, 3. This is easy enough to count to do its counterpart over here. The 120 is 0. At 180 we're -3, so it actually comes inside, so it's right here. That's tricky. We got that 0, we got that 3. Oh, that 0 we didn't actually get, but we kind of did because we already have a point there, and so on. So when we go to connect this, I'm still going to start right here, okay, and I'm going to still make that kind of nice round shape like we did before, and then I'm going to come in here and make this little loop-de-loop. And that actually is the name of this one. It's a Limasson, Limasson, with an inner loop. That's what it's called, okay? And this happens whenever the A value is less than the B value because it makes the radius go negative. So if the radius goes negative, then we have this inner loop going on here, inner loop. That's big in calculus because they might ask you to do stuff like finding the area of this part right here, and we need to know what values form this. So we have to have some sense of where this is falling in terms of the angle measurements that create it, okay? Next we got r equals 5 plus 3 cosine theta. So I will start up here at 5. My amplitude is going to bring me up to 8 and down to 2. And it's cosine, so it's going to go up and down. Okay, right there is going to be pi over 2, pi, and 3 pi over 2, and 2 pi. Okay, I'm just going to cross off the 30s because we're not going to use them. I don't want to get confused like I almost did last time. I'm going to start off with 8, then it's going to go to 5 at this 90, then all the way down to 2 at 180, back to 5 at 270, and up to 8. Next, I will do 5 plus 3 times 1/2. That's going to be for quadrants 1 and 4, so that's going to be some crazy number, right? 6.5, 6.5, 6.5. Then I'll do the same exact thing, but minus. So that's going to end up as 3.5, 3.5, and 3.5. Now that I have that table filled out, I will come over here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, then 6.5. So 1, 2, 3, 4, 5, 6.5. I'll trace that along and put its counterpart over there. 90, we're going to be at 5. 1, 2, 3, 4, 5. I will just trace that all the way around to put the 270. 120, we're going to be 1, 2, 3.5. And I will put its counterpart right here at 240, right? There we go. And let's see, at 180, we're going to be 1, 2, right there. And I believe that's all of them. And this one is, I find, the hardest one to draw because you can't really see what's going on here, but there is still a little like heart shape like we had in the very first one, okay? So there's this little indent there, and what we actually refer to this one is called a dimpled Limasson. Okay, and it's dimpled because of that little part right there. So what makes it different from the first one connected to 0, 0. This one does not. Okay, so it's off of the origin, and that happens whenever we have this value up here. The official rules for it, very official, is actually that. So it's when basically A is bigger than B, but it's not twice as big. Last one of these guys, we got r equals 4 plus 2 cosine theta. Okay, so I'm going to have a midline at 4. Amplitude's going to bring me up to 6, down to 2. All right, so I'm not hitting 0, so it's definitely not like the first one that made a heart, because that one we hit 0. It doesn't go negative, so it's not going to be the inner loop, because the inner loop has to have a negative radius. So we'll see what makes this a little bit different from the dimpled one that we just did. So I will just graph my little cosine up there. I'm going to cross off all of the 30s so that I don't get confused. I'm going to have 6, then 4, then 2, 4, and 6. So I'm just following the pattern and skipping the 60s. Next, I will do 4 plus 2 times 1/2, so that's going to be 5. That's going to go in the 2 positive ones. Then I will do 4 minus 2 times 1/2, which is going to give me 3, and that goes there and there. So let's plot this and see what's going on. 1, 2, 3, 4, 5, 6. At 60, we're going to be at 5, and at 300 we will be as well. Then we'll be at 4 and 4. Then at 120 we'll be at 3 and 3, and then we'll be in here at 2. So this one is tricky, and this happens whenever A is greater than or equal to 2 times B. But for us, it's basically whenever A equals 2B. We get this kind of flat surface right here, and then it rounds itself all the way around. Its official name is called Convex Limasson. I personally like to think of this one as the dodgeball, because I view this as a dodgeball that is hitting someone's face, so the dodgeball is compressing and flattening, and this person is just not having a good time here. So that's how I think of this one. Whenever A equals 2B, it's the dodgeball. So to summarize, when A equals B, we get the heart-shaped. When A is less than B, we get the inner loop. When A is greater than B, we get either the dodgeball, which happens when A is equal to 2B, or we get the dimpled one, which is when it is not equal to twice as much. All right, next we got these cool ones. These are called lemniscates. So we have r squared equals 25 cosine 2 theta. All right, so I'm gonna kind of graph this, and it's gonna be a little bit weird when I do, but that's okay. I'm gonna graph this up to here, say this goes up to 25, it's gonna go down to negative 25, and it's 2 theta, so that means I'm going to get 2 full periods of this before I hit 2 pi right there. But let's think about this here. This is r squared. Can a squared value ever equal a negative? The answer is no. So what we do is basically ignore this whole part. So when it comes to graphing this, what we'll end up having here is, let's see, I needed to label a couple more things here. The normal period would have been 2 pi. We're dividing that by 2, so it's pi. So our x scale is pi over 4. So this is going to be right here, pi over 4. So I know that from 0 to pi over 4, we're in quadrant 1. Okay, so we have a petal that's chilling in quadrant 1. Now from here all the way to here, we're undefined because it can't be negative. Next we have from here, and it'll go all the way to here, we'll have a petal here. So this is actually going to split itself, part in quadrants 2, part in quadrants 3. By the way, that's pi right there. Then from here to here, we're undefined again. Okay? Then we get this last little bit. This will be in quadrant 4. So when we graph this, it does something kind of neat. First is, this is r squared equals 25. So we're going to be at 5. It's going to come down until it hits 0. So that was this part of the graph. Then it basically does nothing, 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 nothing. And then it starts right here at 0 and then increases out to pi, and then comes back down to 0, then nothing, 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 and then it continues right here. So it does this really weird shape where it goes like this when it graphs it. And it makes an infinity, basically. Or, the way I like to think about it is, this is a 2-petal rose curve. So when it's r squared, it's 2 petals, and we can follow all of our same things as long as we remember that if it's r squared, then that equals 2 petals. Okay? That means that they're 180 away from each other. We need to figure out where it starts. It's cosine, so that's going to be 0 equals 2 theta, so it's going to be theta equals 0. And its max radius is going to be whatever the square root of that is. So max r is going to be 5. So we can treat this like it's a 2-petal rose curve. Kind of neat.